Alright guys, this problem is going to deal with limiting excess reactants. So first thing, for a reactant to occur, you need a reaction. So what are our reactants? We're going to react sodium hydroxide with sulfuric acid. Okay? And I'm just going to erase that line that I kind of put through there. There we go. Okay, so what is sodium hydroxide? We had this earlier. Sodium is 1 plus, hydroxide is 1 minus. So there you go, there's sodium hydroxide. It's a salt, so it is a solid. Just gonna erase, too much. So sodium hydroxide is a solid. And then what we do is we add that to sulfuric acid, which is H2SO4. And to be an acid, it has to be aqueous. This is very similar to what we had up top, right? So I think it's the exact same problem that we balanced. So when we do this, the ions switch place. So the cations switch. This is one cation, sodium. This is another cation, hydrogen. The hydrogen comes over here and bonds with the OH. When you have HOH, you get water. When you have Na and SO4, you get sodium sulfate. So here is sodium sulfate. It's a salt. It is an aqueous salt. And then here you have water, which is H2O, which is a liquid. Now we have to make sure that we balance all of the formulas, which I did. The sodium there's two of them, 2 hydrogens, 1 sodium there. But I also have to balance the equation. So I need 2 sodiums on the left and on the right. And then sulfate's 1 sulfate. But then I have 2 oxygens and I only have 1 oxygen here. So I'm going to put a 2 here. And then I have 4 hydrogens. 2 hydrogens plus 2 hydrogens, that's 4. So we're good. So if I react this and I have 2 moles of sulfuric acid, so I'm going to put what I have underneath the equation. And I have 150 grams of this. Now, here I have 150 grams. We haven't done this yet. Which reactant will be the limiting reactant? Which will be the excess reactant? Okay, let's try it out. So I can convert these moles of sulfuric acid into salt. Let's do that. So if I have 2 moles of sulfuric acid, and I can convert this very easily into moles of sodium sulfate. Super easy to do that. So here's 1 mole of H2SO4, and there's 1 mole of sodium sulfate. So 2 times 1 divided by 1 is just 2. I don't even need my calculator for that. So I can produce 2 moles of sodium sulfate if I react all of the sulfuric acid. But we need to check both reactants. So I need to figure out how many moles I have of this. And we don't know how many moles I have of that. So what we have to do is we have to find the number of moles that are in 150 grams of sodium hydroxide. Well, sodium weighs what? Weighs 23, oxygen weighs 16, and hydrogen weighs 1. So if I added all those up, I'm going to do that maybe right over here, just so it looks a little neater. 23 grams for the sodium, 16 grams for the oxygen, and only 1 gram for the hydrogen. If I add that up, I get 40 grams for every mole of what? Of sodium hydroxide. So now I'll take this 150 grams. So I have my 150 grams here of my sodium hydroxide, and I multiply that. I say, okay, so if I have 1 mole of sodium hydroxide, how many grams do I have? I have 40 grams. I just figured it out right here. Now 150 divided by 40 gives me 3.75 moles. So I have 3.75 moles of sodium hydroxide. So I'm going to put that number in right here. 3.75 moles. Some of you guys might be saying to yourself, well, I have more moles of sodium hydroxide than I have of sulfuric acid. So sulfuric acid must be my limiting reactant. Is it? I don't know. Let's take a look. So now if I multiply my 3.75 moles of sodium hydroxide and I convert this into sodium sulfate so I can compare it with this 2 moles. What do I get? So if I have 1 mole of sodium sulfate, where did I get this 1 from? All these 1s, by the way. I got those 1s from right here and here. From the balanced reaction, when we do stoichiometry, is what we're doing. We're doing stoichiometry. We use the coefficients from the balanced reaction to convert. Down here I don't put 1, down here I put 2, because I'm converting out of moles of sodium hydroxide. So 3.75 times 1 divided by 2 is 1.88 moles of what? Of sodium sulfate. So this, should have maybe circled that in a different answer, in a different color. This is, there we go, is my limiting reactant, is my theoretical yield, excuse me. I just fell into one of the pitfalls there. This is my theoretical yield. This one I cross out. I crossed it out because it never happens. I'm going to get my green marker over here. I'm going to say, hey, this guy, he is my limiting reactant. This is, I'm going to erase that stuff, just make this a little bit neater. This guy up here, my sodium hydroxide. My sodium hydroxide is my limiting reactant. And what about my other reactant, my sulfuric acid? It is my excess reactant. I know this because I can make more of the product with this reactant. So this is excess. I can never make this much because I run out of that limiting reactant first. So this is a theoretical yield. Okay, we can highlight some of this stuff. And my theoretical yield is here. This is my excess reactant. This is my limiting reactant. Okay, now let's go back in and let's answer the rest of the problem. The rest of the problem says, well, based on the given amounts of reactants, how much product can you theoretically produce? And it says, show your work and calculate theoretical yield for all products. So, okay, well, this is the answer for the salt. But now I also need to figure out the water. So I'm going to scroll up just so you can see the balanced reaction. Here's my balanced reaction. I have 2 waters for every 2 sodium hydroxide. So this is really easy. Right? So I'll just put, my apologies. I have 3.75 moles of my limiting reactant of my sodium hydroxide. And I convert that into 2 moles of water for every 2 moles of sodium hydroxide. And I can do this math in my head. 3.75 times 2 divided by 2 is just 3.75 moles of water. This is also my theoretical yield. Okay, it is also my theoretical yield. So this one and this one are my theoretical yields. Theoretical yields. So it's just the yield of the water and the yield of the salt. So there's my answer. I could rewrite this answer down here and just say, like, also I have 1.88 moles of sodium sulfate. I could have both of these, right, as my theoretical yield. And if I wanted to refer to the work, I can be like, hey, here's my work. I don't need to show it again. Just showed it. Okay, so there's that answer. Now what if the reactants of one, this is another totally new problem. We have 1 molar nitric acid with calcium hydroxide. And what it produces water and calcium nitrate. So this is an acid-base problem. Similar to this was also an acid-base problem up here. So it's a very similar problem, but what's different is I'm giving you molarity. I haven't taught you this in class yet. So if you don't know how to do this problem and you try it, it's pretty hard. Alright, so let's try it. Let's write out the question first, the reaction. If I have nitric acid, it looks like this. Nitrate ion with a hydrogen. Then if I have calcium and hydroxide, I did this earlier, it looks like this. And that's going to be a solid. Now if I mix that, I will get water, and I will get liquid water, and I will get calcium nitrate. And I have to balance out the nitrates because calcium is 2 plus, nitrate is only 1 minus. So to balance it out, we're putting a 2 here. This is an aqueous salt. This is AQ, the best AQ I've ever drawn, but that's AQ for aqueous salt. Now I've got to balance this reaction. So I have 1 calcium on each side, we're good. I have 2 nitrates on the right, so I will put 2 nitrates on the left. I have 2 hydrogens here, I have 2 hydrogens here. I have another 2 hydrogens here and 2 oxygens. I only have 1 oxygen here, so I'll put a 2 here. Now I have 4 hydrogens, I have 2 plus 2, I have 4 hydrogens, we are balanced. Okay, now this is 1 molar, so I have 1.00, capital M stands for molar. I will explain to you what molarity means in a second here. I have 2.25 liters of this. I have 2.25, that's not a 5, let's try that again. 2.25 liters of this. In here I have 200 grams of this. 200.0 grams of this. Well, how many moles do I have of this? And how many moles do I have of this? I'll put the moles of this on top, because I ran out of room on the bottom. Well, let's check it out. Let's see how many moles we have. What I'm going to do is, I'm going to tell you something really quick. What this capital M means, it means moles per liter. That's an L. Per liter of solution. Okay? This is per liter of solution. And this moles is moles of solvent. What do I mean by solvent? Solvent is, excuse me, it is not moles of solvent, it is moles of solute. Okay? So moles of solute over liters, plural, of solution. The solute is what dissolves into the solvent. So for instance, this nitric acid, 1 molar. What does that mean? That means that if I have 2.25 liters of this, then I say, well, for every 1 liter, how many moles of nitric acid did I have? Well, if I had 1 liter, I also had 1 mole, because it was in a 1 molar ratio. 1 over 1 would just be 1 over 1. Easy. All right. So 2.25 times 1 divided by 1 is just 2.25 moles of nitric acid. So now I have the number of moles of my nitric acid. So I have 2.25 moles of it. All right, cool. So now I could convert this into, because I want to find the excess and limiting reactant. So I can convert this to, I'm going to erase this really quick so I have some extra room. I can convert this into my product. So what I do is I say, okay, well, if I have 2.25 moles of this, I'm going to convert it into calcium nitrate. Why not? So if I have 1 mole of calcium nitrate for every 2 moles of nitric acid, then 2.25, some of you guys have already done this in your head, divided by 2 is 1.13. So it's 1.13 moles, and I believe it's 1.125. I think my calculator, it has gone through a weird little rounding mode. I got to get it off of that. So I have 1.3 moles of, not nitric acid, but of calcium nitrate. Okay, that might be my theoretical yield, but I need to test the other number of moles out. So this calcium weighs 40 grams. This hydroxide weighs 17 grams each. So 17 plus 17 is 34 grams. So total this weighs 74 grams. So what I do is I say, okay, if I have 200 grams of calcium hydroxide and I multiply it times 1 mole of calcium hydroxide for every 74 grams. And what I get is